the name of the presentation is 5 Easy Steps to Make Any Hydronic Heating System More Efficient. 5 easy steps to make any hydronic heating system more efficient. Whether you're the Jackson 5, Hawaii 5.0, or anything like that, we want to be able to count to 5 and apply each one of these 5 steps to help your customer have a more efficient heating season, help cut their fuel bills a little bit. You may have customers out there that would really, maybe they have an older boiler or even not so old of a boiler, but it may not be the most efficient thing out there, and they're looking for ways to not feel the heating crunch this winter. So what we want to do is share with you 5 pretty simple ideas, relatively inexpensive ideas, that have a lot of bang for their buck, that will give your customer fuel savings that'll matter to them. So let's get started. The first one, and we've had webinars on this before, and this is pretty much, I think, standard operating procedure for the dedicated heating professional, for your service customers. Before the heating season really gets into full swing, conduct a combustion analysis on the unit itself, whether it's a high efficiency boiler, standard efficiency boiler, etc. Get that sucker working as efficiently as it possibly can. Take all of the proper readings, make all of the proper adjustments, and give that thing a tune-up so it's as fine-tuned as possible. It's way better than guessing. Used to be, and I don't know if it really used to be, but people think it used to be. Back with old oil burners, you could kind of adjust the oil to oxygen mix, the fuel to oxygen mix, and eyeball a pretty good flame. A lot of the old-timers think they could do it pretty good and didn't need any tests. Well, they could probably do okay, and when oil was 60 cents a gallon, who the heck cared? Well, oil isn't 60 cents a gallon anymore. It's upwards of anywhere between $3.50 and $3.90 a gallon, probably going to get up over $4 before the winter's over. You don't want to eyeball. Natural gas, of course, is a little less expensive, but it's not cheap. You don't want to eyeball, especially if you're dealing with today's real high efficiency equipment, because you really can't eyeball. You don't have much of a window to see the flame through. So you've got to run your tests. You've got to do a combustion analysis. Obviously, you're going to measure your stack temperatures. You're going to measure O2 and CO2 to make sure you can determine how much fuel is being used to make a certain amount of heat. Now, how much, or better yet, how much usable heat am I getting out of every unit of fuel that I burn? Now, that's going to tell you how much heat you have in the boiler. That's step 1 of efficiency, making sure the boiler itself is working as efficiently as it possibly can. That's not the final part of the tail, however, because you still need to effectively and efficiently get the heat out of the boiler and send it to the rooms to provide comfort. If you have the boiler working super efficiently, but the delivery system's not working as efficiently as one would hope, well, then you're not making really good use of what you're doing. You don't have an efficient system. You simply have an efficient appliance. So we want to make sure we not only maximize the efficiency of the appliance, but also maximize the efficiency of the delivery system. And that's what we're going to talk about in parts 2 through 5. Part 1, we've got to get that boiler working at its peak efficiency so we know how much fuel is being used to make the heat that we need. It is a must. Combustion efficiency really is a must. When you improve the efficiency 1%, if you up that efficiency rating 1 percentage point, you drop fuel usage 1%. So if you fine-tune a burner 2 to 3 percentage points, you're going to reduce fuel usage by that much. And it's a fairly simple thing to do. Okay, it doesn't require a huge investment. You've got the tools. You're making the service call. It's a great way to fine-tune that piece of equipment. It's also a safety issue as well. You want to control carbon monoxide because that is a killer. And it's also an environmental issue as well. We want this program we want the boiler to be environmentally sound. CO and NOx are hazardous, and CO2 is a greenhouse gas. And the more we can reduce that output, the better it is for the environment, the safer it's going to be for the people living in the structure, and the more efficient the burner is going to be. A friend of mine has a really great analogy for high-efficiency heating equipment. He says it's a lot like an Italian sports car. When you have an Italian sports car tuned up and running right, it is the greatest thing on earth to drive. But it's a little fussy, and if it's not maintained, if it's not tuned up properly, it doesn't run smoothly, it doesn't run effectively, it doesn't run efficiently. It's not as fun of a car to drive. I think that's a really good analogy for high efficiency heating equipment. Keep them tuned up, they'll give you years and years of truly outstanding and highly efficient service. So combustion analysis, it is a must. For more info on combustion analysis, because guys, I am by no means an expert on combustion analysis, we do have an archived webinar in the neighborhood called Combustion Analysis. Do it right, get it right. We put this thing on live several months ago for you with Bruce Marshall of the TACO rep in New England, Emerson Swan. Bruce holds the title, the official title of the smartest man I know. If he doesn't know it, it probably doesn't exist when it comes to combustion analysis. We did a webinar with Bruce. We have the webinar available for you to download and view at your convenience, as well as a PDF file of his actual presentation is available there for you as well. All you need to do is go to the front page of the neighborhood, find this picture on the right-hand side where it says click here to view webinar. You can download that. Click here to view PDF. You can download that as well. And that's really what where you'll get really good technical hands-on information on the ins and outs of doing a combustion analysis, what to look for, what the numbers tell you, what's a good number, what's not so good a number, and how to adjust the number, how to adjust your settings so you maximize the number for your particular piece of equipment. So step one in making any hydronic heating system more efficient, and that's kind of, you know, you got to pass go to collect your $200 here. This is step one. That's the first thing you got to do, and that would be a combustion analysis. Now, if we want to have some fun, a really immediate way to have a huge impact on fuel consumption on an existing boiler that your customer has, that's going to be to add boiler reset. Add boiler reset to an existing boiler that obviously doesn't have one. Now, a modulating condensing boiler of fairly recent vintage is probably going to have one on it anyway. But we're talking about older cast iron boilers that are still in perfectly good usable working order. We want to make sure that they're as efficient as they can possibly be. So we can add a simple boiler reset to an existing cast iron boiler. The goal when adding reset to any boiler, of course, is to match the boiler output to the heating load. We want a control that's going to automatically adjust the boiler temperature based on how cold it is outside, and how cold it is outside is going to determine what the actual BTU load of the structure is at any given point in time. What we're after here is as it gets colder outside, we want the water in the boiler to get hotter. As it gets warmer outside, the boiler doesn't have to make water so hot. The other key, which I'm going to explain in a little bit of detail in a couple slides, is whatever boiler reset control you add to an existing cast iron boiler, it's really important to make sure that that particular control also automatically adjusts the boiler's firing differential. That's going to keep the boiler from short cycling badly in milder conditions. We'll discuss that more in detail in a couple minutes, but I wanted to just get that on the table. The control needs to automatically adjust the boiler's firing differential to enhance efficiency and economy when it doesn't have to make 180-degree water, when it's only making 160-degree water or 150-degree water. We don't want that boiler to short cycle. We'll explain how that works in just a couple slides. One of the things that is a benefit when you reduce the boiler temperature, well, quite simply, you use less fuel. All right, you don't use as much fuel. You don't use as many gallons of oil or therms of gas to get water to 160 degrees as you do to 180. Other benefits of keeping temperatures lower within the system is that you reduce standby losses at the boiler. The boiler's not as hot. It's not going to lose as much heat through the jacket. It's not going to lose as much heat through the chimney, and you're not going to have as much piping loss and other losses to unheated areas. That all enhances overall efficiency. Now, a real conservative estimate, conservative savings estimate for adding outdoor reset to a cast iron non-condensing boiler is anywhere from 5 to 15%. There certainly can be higher. There are other enhancements you can do to the system to even further enhance that savings. But a good conservative estimate for a cast iron non-condensing boiler in good working order, by adding outdoor reset, you can reduce fuel bills, conservatively speaking, 5 to 15%. A lot of people people look at 5 to 15% and say, well, boy, that ain't much. That's not much. That's not a whole lot of bang for the buck. That's hardly worth it. Well, again, I would say when fuel oil was 60 cents a gallon or natural gas was 35 cents a therm, I'd probably be in agreement with you. But it ain't anymore, and it isn't going to be anytime soon. So if you don't think 5 to 15% is much, think again. It can have a pretty dramatic effect. Let's consider an older home that's heated with oil. An older home heated with oil, not a very large home, that uses an estimated 1,200 gallons of fuel oil per year. Not an outrageous assumption in the cold weather parts of this country by any stretch of the imagination. About 1,200 gallons of fuel oil per year. And when we're talking about a conservative estimate, 5 to 15%, gang, let's split the difference. We'll call it 10. Okay, we'll use 10% as our estimated fuel savings. If we use 10%, if we reduce our fuel consumption 10%, well, 10% of 1,200 gallons is 120 gallons of fuel. Right now, I checked yesterday online, right now the average cost of fuel oil in the Northeast is anywhere from a low of $3.50 to a high of $3.89, or $3.89.99, we'll call it $3.90. All right, if we're somewhere splitting the difference, let's say $3.65. If fuel oil is $3.65 a gallon and we reduce consumption by 120 gallons, that's $438, gang, the first year that we're not spending on fuel. So a $438 savings is a pretty immediate impact, and that's first year. A comparison of fuel oil prices today compared to 2010, same date 2010, shows that prices today are roughly anywhere from 33 to 36% higher than they were a year ago. That's up by at least 1/3. So if we were to project that, and I know it's always risky projecting what it might be in the future, but we have the past to look at. If fuel oil is 1/3 more expensive next year, and we're still saving that 120 gallons, the estimated savings, of course, next year would be 1/3 greater than 438. That's roughly $580 worth of savings next year. So if you look at it in 2 years, this add-on could conceivably save up to $1,000 in fuel consumption. Now, I don't know about you, but to me, that's an attention getter. That's most definitely an attention getter. Now, that's assuming they don't do anything differently. You know as well as I do, gang, you tell someone, well, this is going to make your boiler more efficient. Well, the first thing a lot of folks do is say, well, then I could probably turn the thermostat up a couple degrees and be a little warmer, and I'm still ahead of the game. Well, sure, they can absolutely do it. It's their home, but it's going to impact their savings. I hope that makes sense. I want to do just a quick status check with you, too, guys. Just type it in your question thing. Are we doing okay? How's the pace? Is the pace fine? Do I need to go faster, a little bit slower? And any questions you have, now would be a good time to throw them in. So just give me some feedback. Let me know how we're doing. Okay. So far, so good. Okay. John Langan, I like you. You're easy to please. Perfect. Where do you get the boiler resets? Len, I'm glad you asked, my friend. In Australia, I'm not entirely sure, but we'll discuss some Taco products here in a little bit. Okay. Good pace. It's bloody early here. Yep. Good morning out there in down under. We do have, I hope the rest of you know, Len comes to us from Australia, so it's good to have an Australian wet-head in the group. All right, excellent, very good. So again, I guess the question to you guys is, and really more importantly, the question you should pose to your customers: is this a good investment? Is this a good way to spend some money to enhance their system? And the other advantages of outdoor reset, adding outdoor reset to a cast iron boiler, is that you'll have fewer cycles, but your cycles will be longer. So all of your moving parts in this boiler will have fewer cycles, and that's going to help them last longer. And that is a down-the-road service benefit. You're much less likely to wear out the moving parts within a system, and that's a good thing too. So what's involved in putting one of these things together? All right, what's involved in putting one of these things together? Well, from our standpoint, the Taco PC700, it's a power add-on control with an EXP relay, might be the easiest way to go. It might be the PC700, I think, is maybe the simplest outdoor reset control that you can add to a boiler that there is out there. It's not quite plug and play, but it's pretty much as close as you can get. The installation is easy. The wiring is easy. Just take a look at that Molex plug right there is really all you have to do to power it up and to integrate it into the system. You have to wire up 2 additional sensors, but that's all. So the only wiring you need to do to integrate this into the system is to plug that into an EXP relay. Okay, and the programming, depending upon where you are and how you want to set it up, might be even simpler than the plug-in. Okay, we do have a comment from Gregory Neely down in Kansas City. The difference between our February low in winter and summer high in July was 119 degrees. Wow, that's a big jump. It's pretty warm. That means it's pretty warm and pretty cold. Here in Minnesota, it's pretty darn close to that. Our high was 107, and our low was, I think, 22 below. So I think we might actually have you beat. That's 129 degrees. But those are pretty wide swings. I mean, from hot to cold, man. That's amazing. That is amazing. Alrighty. So how does the reset control work? Well, what it's going to do, if you take a look at the chart here, it's going to calculate the required boiler temperature based on weather and based on programming. It's going to calculate the boiler temperature based on outdoor temperature and programming. Basically, what it does is it looks at 4 different programming points, and it puts those points, those 2 sets of points, on a graph, as you see here, and then just connects the dots, and it's going to operate along that line. Let's take a look at this chart. Down at the bottom, you see outdoor air temperature. And let's say in this particular part of the world, our outdoor design temperature, the quote-unquote coldest day of the year, or the temperature upon which we've based the heat loss of the structure, let's say it's -10, as it shows here. And let's say we want the boiler to deliver 180 degrees on that quote-unquote coldest day of the year. So on our chart, we find -10 on the left-hand side, and then we go up and we find whereabouts 180 degrees would be, and we put our high-end point there. Then down on the other end, we have what they call the reset ratio starting point. 70 degrees indoors, 70 degrees outdoors. When it's 70 degrees indoors and 70 degrees outdoors, the boiler there's no heat loss. So really what we're telling this now, 70 degrees indoors, 70 degrees outdoors, we want the boiler to make 70-degree water. So 70 at 70 at 70 is our starting point. Now I know we're going to be putting this on a cast iron boiler, and we most certainly don't want to be going down to 70 degrees. We don't have to. There's provisions for that. But that's the anchor. That's the starting point of our line. And essentially what now happens here is we're right up here at -10. If you see my cursor, -10, the boiler's making 180. 70, it's going to make 70. The rest of the heating season, it's going to bop back and forth in between these two points. So at 10 degrees outside, the boiler is going to be making what looks to be about 150-degree water. At 5 degrees outside, it'll be about here. At 20 degrees outside, it'll be right about here. So it's going to bop up and down. The other thing is, a huge portion of your heating season, in excess of 50% of your heating season, you're going to be spending at about 60% or 70% load or less. So a huge portion of your heating season is going to be spent right around here. So if we can heat the structure for most of the heating season with water temperatures right around in here, instead of always being up here, well, that's got to help us, and that's got to help us an awful lot. So that's kind of where we're at. Okay. Warm weather shutdown, Moher says warm weather shutdown is also a great feature. What warm weather shutdown does, and these include warm weather shutdown, is, yeah, you've got 70 at 70. That's where the anchor point is. But you can say, you know, hey, it's 60 degrees. I want warm weather shutdown. What that says, it's 60 degrees. The boiler's not going to do nothing. All right, boiler's not going to make heat. It's not going to turn on to make heat because we don't want it to. So if it's 60 degrees outside and someone turns the thermostat up to 80, well, forget it. It's not going to do anything. So that's another great feature to help save energy when you really may not need the boiler to run. Okay. So essentially what the outdoor reset's going to do is it's going to tell the boiler when to fire, and it's going to tell the boiler what temperature to fire to. It doesn't always have to be 180 degrees. Talked to you a little bit before about that differential. And monitoring and automatically adjusting the differential is really, really important for an outdoor reset control with a cast iron boiler, because it doesn't have a modulating flame like a ModCon does. It's going at one speed, based on the nozzle for the oil boiler or just based on the gas valve for a gas boiler. It's going at one speed all the time. When it's really cold out, well, first off, let's define a differential. This is a look at what happens when you have, let's say, a 10-degree differential. And just for the sake of argument, let's say the water temperature we want, the set point we're looking for is right here, 160 degrees. That's the set point for the boiler. That's the quote-unquote high limit. A 10-degree differential means the boiler's not going to kick on until we're 5 degrees below that differential, and it's going to continue to run until we're 5 degrees above the differential. That band of temperature is going to average out to, let's say, 160. But it's not going to just stop right at 160. It's going to overshoot a little and undershoot a little, but we want to keep that relatively tight, especially when it's cold. So what's going to happen here is you see the boiler in the first cycle, that boiler's running. 160 is the set point, but bang, it hits 165 and shuts off. A little bit of overpass here, and then it starts to cool down over time, and it's going to go off and stay cooler and cooler and cooler until we hit 155 or 5 degrees below that set point. Then it fires back up. We got a little droop because it's got to catch up and offset that swing, and then it's going to keep running until we hit 165 again. Now, the reason you have what you want an automatic adjusting differential is when it's really cold out and you're in peak load conditions. You've got the highest amount of heat loss. You want to make sure you have BTUs in the boiler to go out there and satisfy the heat load. So at that point, you may want a 4 or a 6 degree differential on your boiler. However, a 4 or 6 degree differential on the boiler when it's when I only have to make 150 degree water, and you have a boiler nozzle firing at a certain amount of gallons per minute or a gas valve firing at certain BTUs per hour, we'll hit that really fast. So what we're trying to do then, what the control will do then is if I only need 150 degrees, maybe that differential stretches out to 20. So the boiler doesn't fire until you hit 140 degrees, and it doesn't stop firing until you hit 160. That allows you, even under those milder conditions, the shoulder seasons, October, November, March, April, or just milder conditions when we don't need the boiler to fire up to high limit, we still get nice long burn times to maximize efficiency. So you want to make sure your control has an automatic adjusting differential. Okay, I hope that makes sense. It's kind of an important feature. Okay. Daniel Eager asked a question, would an outdoor reset help electric boiler efficiency as well? That's a good question. I know there are electric boilers that have a built-in reset, Daniel, that they stage the elements. And it could be based on system delta T or on outdoor temperature. I know there are several out there that will have multiple elements, and they can stage the elements based on how cold it is outside. And that certainly does help its efficiency. I'm not entirely sure. I mean, I can't see if the boiler just the boiler just starts when there's a call for heat. How we tell it to start and when we tell it to start would probably help. This type of a reset does work well when you have a lot of mass. Electric boilers generally don't. I would check with the boiler manufacturers to see what they have for reset or for staging the elements on those boilers. I think that makes it work. How will this control interact with summer-winter boilers? I'm presuming you're asking, Jim, and clarify for me if I'm wrong, that we're talking about boilers that have to run to make domestic hot water with an indirect. We'll get to that one in just a couple slides. That's an excellent question. That's an excellent question. We have ways to make that work, if that is, in fact, your question. But I think using the boiler to make domestic hot water as well, we have a reset override function. Okay. And Jonathan Hicks asks, assuming the desired indoor temperature is the same, doesn't the boiler have to run longer to heat the inside? As such, is it more efficient to run longer at a lower BTU per hour? Okay, let me see if I can digest that question there, Jonathan. The desired indoor temperature is the same. Doesn't the boiler have to run longer to heat the inside? When it's colder out, sure, absolutely. When it's warmer out, at the same firing rate, no, because we're not taking as many BTUs out. We're taking fewer BTUs out when it's warmer outside, because the heat loss is simply lower. That boilers make, boilers got a, let's say it's an oil boiler and the nozzle's at 0.75 gallons per minute, or 0.75 gallons per hour, excuse me. That's what it's going to burn. It's going to burn at that rate, and if it makes the BTUs you need, it's going to hit your high limit, it's going to shut off in short cycle. So by lowering the water temperature that the boiler has to make, but by creating a wider differential, we can get it to run longer under milder conditions. I hope that answers your question. Again, I'm not sure I understand. What additional piping or controls are generally needed to protect the cast iron boiler from condensing? Excellent question. We'll give you two alternatives here in just a moment. And good question there, Michael, and we will get to that. What about a 90% aluminum non-modulating boiler with an indirect fired domestic water with an indirect? Okay, a 90% aluminum non-modulating boiler. So there's no reset control on that boiler as we speak. We can certainly add outdoor reset to that, and we're going to show you exactly how to do that in just a minute. So I hope I will be addressing those questions. If not, fire them back at me. Okay. We did talk about Michael did ask about protecting a cast iron boiler. One of the functions built into the PC700 is what we call partial reset or minimums. What's going to happen here is that the boiler will have a minimum. It could theoretically go all the way down, but for a cast iron boiler, we set a minimum. We set a floor. You're not going to go below this temperature, so we don't condense the boiler. We don't want to condense those flue gases or send really low return water temperatures back. So we set that floor, and that's going to protect the boiler. And it does an excellent job. And you will find most of the heating season most of the heating season is going to be spent right in here, as opposed to firing up here all the time. Most of the heating season is going to be spent right in this area, and that enhances your overall economy of operation. Let's take a look at a problem job and what we can do for a solution, and you'll see some of the controls and additional piping on an existing boiler. I will tell you this, Michael, if with the right control, with that floor, that PC700, the electronic controller won't let you go below a certain temperature. You don't need to do any additional piping to protect the boiler. But let's take a look at this problem and give you two solutions. Let's say we have 3 zones of hydronic heat with 1 indirect hot water tank. So 3 zones plus the indirect. The boiler itself, let's say it's only 7 years old. It's still a baby, right? It's brand spanking new. It's barely been broken. It's barely been broken in. All right, it's barely been broken in. So what you want to do? Do you want to take it out and throw in something of higher efficiency? Well, you could, if that's what the customer really wants. Well, sure, be happy to do it. The thing is, there's nothing green about that. There's nothing green about throwing a boiler that's got another 25, 30 years of life in it and just throwing it away. Okay, there's still plenty of life in that. Let's make it work to its peak efficiency. Well, this customer wants to save some money. Maybe they think, well, maybe we'll convert to gas, and the gas conversion's just not where they want to be. It's a mess. All right, it's $9,000, $10,000. That's not in the budget. They got sticker shock. It's not really where they want to be. Think about what they really want. Their goal, and this is where your discussions with them will help. Your goal with them is to find out what you want. What is it they're trying to accomplish? Well, they want to use less fuel, save some money, not have to spend as much as they did last year to keep the house livable. Forget comfortable, just plain old livable. So how do we do that? Well, we can add the easy reset and have an impact on their fuel bill. Maybe not the same as ripping the thing out, converting to natural gas, putting in a high efficiency boiler, but we can get them some relief without breaking the bank. Here's what we're looking at. This is the existing system. You've got 3 heating zones plus domestic hot water priority. So when you get a call for domestic hot water, the other 3 heating zones turn off. And currently we're using a TACO SR504 4-zone circulator relay. It could be, if you're doing this with zone valves, it would be with a ZVC404, either or. Okay? But this is what we have right now. And this is the electronic part of it. Again, using the circulator relay. I've got my 3 heating zones, zones 1, 2, and 3. The high limit aquastat or the aquastat rather, for the hot water tank is wired to zone 4. You'll see the priority zone 4 switch over here. That's in the on position, so that when zone 4 calls, the other 3 heating zones turn off. We have our 4 circulators wired in down at the bottom here to their respective zones. Then we have our end switch, XX. This end switch goes to TT on the boiler control to fire the boiler whenever a zone calls for heat. Pretty standard setup. Now, to make boiler reset easy, we could do this in one of 2 ways. We have 2 options. Both work fine. It's really 2 different paths to the same destination, and which way you prefer is quite simply which way you prefer. Option 1, we keep the existing SR504. No reason to throw it away. It still works fine. But in order to add the boiler reset control, we need to add an SR501 EXP relay to the setup, and then we have to add the PC700, which is, boom, click done. You plug it in. All right. You keep the existing 504 relay, add a 501 single zone relay, 501 EXP, the expandable relay, and then you add the PC700 reset control to that. Option 2 is the same thing, only different. It's just a different approach. We dump the 504. We swap it out with an SR504 EXP expandable relay, and then you add the PC700 to that control. So either or, both will do it. Both will get you to the same place. It's just, one is a little more compact. One, instead of buying a 504, you simply buy a 501, maybe a little lighter on the materials, but maybe a little bit more on the work. It just simply depends on your point of view. But they'll both get you to the same place. Here's what it would look like using option 1. Adding the 501 EXP expandable single pump relay to the existing system. So we keep the 504. Everything stays wired to the 504. The 3 thermostats, the aquastat, and the 4 circulators, they're all wired to the 504. But we'll make a couple of changes. The end switch, XX end switch from the 504, that was going to TT is going to be detoured. All right, it's going to be detoured to these terminals right here. Okay, they're going to be detoured to the thermostat terminals on the 501 EXP. So that's where the end switch from the 504 is going to go, to the thermostat terminals. This 501 EXP is now going to be the relay that talks to the boiler. So a couple things we have to look at when we're looking at these terminals and these switches here. First, when you add a reset control to the 501 EXP, you see this switch over on the right-hand side. That's the reset normal switch, or the mode switch. When that switch is in the normal mode, this end switch over here, this XX on the 501 EXP, when we're in the normal mode, when a thermostat calls for heat on this relay, the end switch closes. So it's a direct link between here and here. Thermostat calls for heat, end switch closes, boiler fires. That's in the normal mode. In the reset mode, we change that. In the reset mode, the thermostat tells the PC700, which is wired in over there on the right-hand side, or on the left-hand side rather, when we're in the reset mode, the thermostat, or whatever input we have to the thermostat terminal, sends a signal to the PC700 reset control that there's in fact a call for heat. It says, hey, PC700, we got a call for heat here. What are you going to do? The PC700 says, thank you very much for that information. I appreciate that. I know there's a call for heat. I'm watching the boiler temperature and I'm watching my programming. When I decide that when we need to fire the boiler, then we'll fire the boiler. And I'll decide what temperature to fire the boiler to. I'm glad you gave me that input, because without that input, I wouldn't know. But I'll determine when to fire the boiler and what temperature to fire it to. So we break the link between thermostat to end switch. Instead, thermostat takes a detour, it talks to the power control. The power control then reads the situation, and then it decides what to do. Should it fire the boiler, and what temperature should it fire the boiler to? Okay. These terminals here, reset, override, are important in this example because we also need to be able to tell the control that there is a call for domestic hot water, both during the wintertime and during the summertime. We need to know to override the reset control, whether it's in warm weather shutdown or whether it's simply in reset and we're only making 150-degree water. We want the control to say, we want the aquastat to be able to tell the PC700, says, hey, I got a call for domestic hot water here. You're going to have to override the reset and go all the way to high limit on the boiler. And the reset control says, yes, I think you're right. That's what we'll do. But we need to have a connection from that aquastat not only to the Zone 4 terminal on the 504 relay, but also to the reset override terminals, as we'll see. Okay. So let's see how this is going to be wired up here. As we said, the end switch from the SR504, instead of going to TT on the boiler, is instead going to go to the thermostat terminals on the 501 EXP. Note that the mode switch is in reset, all right? And we are also connecting the terminals from the aquastat to the reset override. All right, polarity here does matter. If you connect it and then you find that we're always calling for domestic, you know your polarity is reversed, you simply switch the wires and then you'll be in good shape. Okay, so but we will parallel those wires not only to Zone 4, but also to the reset override terminals on the 501 EXP. That's what will tell the PC700 that there is a call for domestic hot water. Then the end switch terminals on the 501 EXP, now those will be connected to the to TT on the boiler. So call for heat, zones 1, 2, 3, or 4. But whenever any one of those zones call for heat, all right, end switch on the 504 makes, goes to the thermostat terminal on the 501 EXP. That sends a signal to the PC700 because we're in reset mode. That sends a signal to the PC700 that there is in fact a call for heat. PC700 says, thank you for that information. I'm watching the outdoor temperature. I'm watching the boiler temperature. Right now we're good. But when the time comes, I will fire the boiler and I'll fire it to what I need to fire it to. And that's how it works. Okay. Note down here, you do obviously have to bring an additional line voltage set to the 501 EXP for power. But that's the only thing you use the 501 EXP for. Okay. Does that make sense? That's pretty simple. All right. That's pretty simple when we're looking at putting this together. What are my pros that would edge me to use the PC700 versus using a Tecmar 256 ODR control? The controls look identical. They do look identical, but they are in fact they're not. This was a joint venture with Takeo and Tecmar. The connectivity, I think, Mo, is the biggest thing, and how easy it is to integrate it into a system. That would probably be the single most, the most appealing thing to you, if that helps you. That it's dead simple to apply here. And when we get into the programming of it, you might find that it's even more dead simpler. It's again just easy to apply. That may be the single biggest thing going for you, and you can apply it to just about anything. Okay. But as far as outdoor reset, they both do outdoor reset, and they both do it very well. Okay. Option 2 is easier than option 1 by all accounts. You simply take the existing 504 standard relay out. You disconnect your low voltage. You disconnect your line voltage. You replace it with a 504 EXP, expandable relay, as you see here. And you reconnect the circulators, you reconnect your line voltage, you don't have, the end switch still goes to the boiler like we had before. We simply connect everything up. We put Zone 4 back into priority just like we had it before. And then we have a reset normal button on the 504 EXP. We'll set that to reset. And then the Molex connector on the PC700 plugs right into the control itself. Plugs right into the relay. And then you wire up your boiler sensor and your outdoor sensor, and you're good to go. It takes up a little less space. It's just simpler. Okay? What's going to happen here is when you're in priority and the system's going to operate exactly as it did before. Heating zone calls for heat. We send the signal to the, instead of sending a signal to the end switch and firing the boiler, the signal goes to the PC700. The PC700 says, thank you for that information. I'll figure out when I need to fire the boiler and what temperature I need to fire the boiler to. When the PC700 decides to fire the boiler, it closes the end switch, and bada bing, we're good to go. And it'll fire up to whatever, 150, 160, whatever the setting is. When Zone 4 calls for heat, we automatically override that reset. We automatically override the reset. It'll go up to the boiler's high limit to make domestic hot water. So pretty simple and straightforward. Another advantage to going this route is, you see where it says plug-in cards. Now, for you folks in most of the U.S., this is still something you're going to be looking at through the end of the year. But an advantage to using the 504 EXP instead of the other solution that we were looking at was you have the ability to add plug-in cards, the PC600 series plug-in cards. It's like adding cards to the motherboard of your computer. They add a little bit of functionality. One plug-in card you have available is a priority protection card, which basically says when you go into domestic hot water priority, this protection card says, hey, cowboy, you got 1 hour, go. If you're not done making domestic hot water in an hour, we're going back to making heat, thank you, because we don't want to freeze the joint up. You add that card, you get that additional layer of protection. The other card that would be of interest to you is a post-purge card, used really commonly with oil boilers. What this does is, it just says when the boiler has finished firing and all of the zones are satisfied and the boiler's just sitting there, what the post-purge card does is it simply runs the circulator for the priority zone, in this case the domestic hot water zone. It will run that circulator for an adjustable amount of time. You can adjust it anywhere from 7 seconds to 10 minutes. And what that will do is it'll help get whatever residual heat that's still in the boiler that we would otherwise lose up the chimney or lose out of the jackets. It takes that residual heat out of the boiler and stores it in the storage tank. Yes, your domestic hot water temperature is going to get higher. At that point, you need a tempering valve on the outlet side of that tank so you don't scald anybody. But better store that energy in a super insulated tank than a somewhat insulated boiler, if that makes sense to you. So that's a plug-in card you can add as well. Now, for folks out in the Rocky Mountains and for the guys up in Canada, for the past several months, you have had the new generation of SR pump relays and ZVC zone valve controls, that the expandable versions of those controls have that functionality built in, and you can select it or deselect it, I guess, if that's the word. You can select it or deselect it with a series of dip switches. And I think those have been working out really, really well, both in the Rocky Mountains up in Canada. We'll be ready for a nationwide release probably by the first of the year. Another nice feature of the new controls is that the existing controls have the lights on the side, and people say, boy, it would be really nice if those lights were on the front, so I wouldn't have to look on the side, or sometimes you just can't see the side. Well, yeah, the new ones are going to have the lights on the front, so you can tell what's going on within the system looking through the front box. So I think that'll be a benefit to you as well. Another question from Mo. Without hogging all the questions, that's okay, Mo. Can this PC700 be used with a ZVC, a zone valve control? Yeah, absolutely. You need a ZVC EXP. All right, the expandable zone valve control. Yeah, but with ZVC EXPs, absolutely, absolutely. Zone valves or pumps doesn't matter. It's just resetting the boiler. So yeah, it is a pretty simple approach. I'm with you there. Okay, what about here's a question from Michael. What about 3 zone valves with 3 separate thermostats and 1 circulator? Is the zone valve controller set up in a similar manner? Absolutely. I think that's maybe just what we were talking about. In this case, you would use your ZVC 404 or ZVC 403 or a 404 expandable relay, where you can add the control to that. Absolutely, absolutely. And in fact, if you had 3 zones, 3 thermostats, 1 circulator, plus you had a circulator for an indirect, you could still use the ZVC 404 EXP and make it all work and have domestic hot water priority. You don't need an additional relay. You can run 2 pumps off of that 1 relay in a kind of slick manner. So I hope that answered your question. There we go. Does it come with the sensors? Yep, comes with 2 sensors, the little white box outdoor sensor that goes outdoors, and then a strap-on sensor for the boiler. It goes right on the boiler supply. The outdoor sensor, of course, should be mounted outdoors. You don't think you have to say that, but sometimes you do. Outdoors, north-facing wall, away from anything that's going to falsify it, like a dryer vent or the boiler outlet. You'd think, again, you wouldn't have to say that, but I've seen them. And this one I learned the hard way, above the snow line. I really don't want to get into how I learned that above the snow line, but above the snow line. Any plan, from Paul Draper, any plan to make these controls talk over a network or wirelessly? Wirelessly at this point, I don't believe we have anything in the skunkworks, but I can't say for certain there, Paul. Network meaning like a computer kind of thing. I think you might be talking about our iWorks control package. The iWorks control package right now is designed for those massive, not muck mansions, but super mansions and light commercial. Over the next several months, we will be introducing a residential version of the iWorks control package that'll do a lot of this same stuff, but only more so. But primarily, the biggest advantage there is it will be able to be controlled online if necessary, controlled and diagnosed online for vacation homes and things like that. So we'll have all those things. Yeah, good question, Len. You don't want a south-facing wall, at least in this hemisphere. I'm not sure about down where you are, Len, but up here we don't want it. We don't want it on a south-facing wall. All righty. I guess my question for you guys is, which option do you like best? Yesterday we had a pretty overwhelming mandate as to what version the group liked better. Type in your question thing which one you guys like better, just so we know. Okay, I'd like your opinion. And in the meantime, it says even with this setup and using partial reset, is the return water temperature maintained above 140 without some type of bypass? Typically, again, if your high limit is 150, your return water is going to be 130 to in the 130 to 140 range. Which, depending upon where you are, is above condensing. If you want to set it up a little bit higher, you certainly can. When it's in that partial load condition, again, that boiler is the control is sensitive to those return water temperatures. At sea level, the condensing point is in fact 127. I know we use 140 for safety, but at sea level, the condensing is 127. I think is it lower or higher when you get up into altitude? I can't remember. Someone at altitude help me out there. But typically, we haven't seen any issues with the return water temperatures in the 130 to 140 range with flue gas, with flue gas condensing. If there is a need, if you do feel a need for a boiler bypass, a simple full-size bypass with a globe valve on it is pretty easy to do. We have not seen the need for that or any issues. Let's see, what do we have? Number 2, we have pretty much you guys are pretty much the same as yesterday. How would this work on a system with 2 different types of radiation, iron rads, radiant, steel rads? All it's doing is making water temperature, Nick. That's a really good question. Set it for the highest water temperature that you're looking for. It's not so concerned. It's not resetting the water. It's not a delivery reset. It's a boiler reset. So really, if a cast iron radiator or steel radiator, does it always need 180-degree water? No, probably only needs 100. It may only need 150 when it's not that cold out. So it's just changing the water temperature, which changes the output of the radiators. But the point is, we want to change the output of the radiators because it's warmer out and the heat loss is lower. So let me know if that answered your question, Nick. I'm not sure if that's what you were asking. Okay, Dave out says there's option 2. Option 2, less wire is better. Option 2 gives you the plug-in flexibility. Absolutely, option 2, but depends on price. Yeah, I mean, you're talking about materials versus labor. It's a good point, Jonathan. I think you're buying the reset control and a 504 EXP, which is more money than buying a reset control and a 501 EXP, obviously. But then it has to be installed. Which do you do better? Which is going to make more sense? And really, it is up to you. But those are the questions you want to ask. Okay, Michael says option 2 because it's cleaner and simpler, but we're using it without any existing controller now. Okay, very good, very good. All righty, excellent, guys, excellent, good. You guys I hope we're doing good. This is a lot of fun. All righty, and again, end switch goes to the boiler like it normally would, and make sure you have the system in priority, and make sure the mode switch is set to reset. Okay, and then you have your sensors for outdoor and for the boiler. Now, programming, we said, is easy. It is factory programmed for a typical Northeast U.S. heating system. But if you're not in the Northeast, don't throw this out because it may be a benefit to you. These are the factory settings. You take it out of the boiler and you don't program it and you plug it in. The factory settings on the right-hand side is how this sucker's going to run. The boiler start temperature and your outdoor start temperature, again, 70 at 70, like we said. The boiler design, the temperature it's going to run to on the quote-unquote coldest day of the year is factory set at 190 degrees. The outdoor design temperature, that quote-unquote coldest day of the year, or the temperature that you based your heat loss on, is factory set to 10 degrees. The boiler minimum, okay, that's the minimum temperature it's going to allow back to the boiler at this point is 140. Automatic differential, warm weather shutdown is set at 70. You can adjust that, and units are set to Fahrenheit, but could be changed to centigrade if you so desire. I want to focus on that 190 and that 10. A lot of folks say, whoa, 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 this won't work. It gets a little colder than 10 degrees where I'm at, cowboy, or I want to set lower than that because I want to be safe. So what folks will commence to do is they'll figure out how to set that 10-degree temperature down to, say, 0. Well, think about what you just did. The way it's factory set, it's set to give you 190-degree water at 10 degrees. If you're thinking you're going to be getting yourself a little safety margin by lowering the outdoor design to 10, from 10 to 0, what you've just done now is you said, I want 190 degrees at 0. So you've actually, instead of giving yourself more, you've given yourself less. Just so you know that that's what you do. Okay. You can certainly adjust those to whatever fine-tuning you want for the specific boiler, for the specific application. But just understand that that's where it's set at. All right, you have it set at 190 at 10 degrees. Okay. Question from Dave says, changing temp to rads lengthens the runtime and helps smooth the peaks and valleys. Absolutely, that'll help your runtime. In rural settings, we have wood-fired or feed-fired boilers in Missouri. These controls would also work for these fuels, in my opinion. Sure. If there are something that makes them feed automatically, yeah. Like an auger on a corn boiler. Sure, it might certainly help there. I think corn boilers are neat because they make the whole area smell like popcorn. I really like them. Okay. Do you need to add 24 VAC to the N switch circuit? No, you do not. Good question, Mo. On the PC700, no, you do not. The N switch is simply an N switch. All integration is done through that relay. How is short cycling reduced since lower temps are reached with a possibly oversized boiler? Good question, Michael. That's where that automatic differential comes into play. Again, it's going to widen that differential when lower temps are needed, so the boiler will have a longer runtime. So again, say we need to make 150-degree water, that differential might bop up to 20. So the boiler doesn't come on until you get to till the temperature gets to 140, and it goes until you get to 160. Okay, so that automatic differential is what reduces that short cycling. Without the automatic differential adjustment, you'd short cycle like crazy under milder conditions, and that doesn't make any sense. It doesn't help us. Okay. Does changing the warm weather shutdown change anything else? The only thing, John, that changing the warm weather shutdown does is that it simply says, hey, it's 60. If I go to 60 degrees, it doesn't change the boiler start or the outdoor start. You really want to leave that alone because that's just the anchor of the curve. What changing warm weather shutdown does is it's a further energy savings device. It says, I know someone might turn the thermostat up when it's 65 degrees outside. I don't want them to. I just don't want them to. I want, if I set the warm weather shutdown to 60 instead of 70, as soon as it's 60 degrees outside, the boiler's not going to fire on a call for heat. Okay, and that's really what all the warm weather shutdown is going to do for you. And it's an energy saving add-on. Now, some supporting documentation for outdoor reset. If you go to TACO's website, and you actually look up the PC700, you go to taco-hvac.com, and you look up in the search section, you just look up PC700, or under products, you look up electronic controls and then boiler add-on controls. You'll find the PC700. On that page with the PC700 is a link to this supporting documentation produced by TACO, distressed by rising fuel prices. What this does is it gives the customer some information on what boiler reset can do for them, how it can help reduce their fuel bills. This is a trifold brochure. This is the one side of the trifold. Some frequently asked questions. There's some information here about what boiler reset controls can do. The other side of the reset is a nice graph, nice pictures on what can be done with a boiler reset and how it helps save some energy. Now, this particular brochure is based on an independent study done by a group in St. Paul, Minnesota, which I'll show you in a second. Another piece of supporting documentation you'll find in the FlowPro blog. I wrote this last September. If you go to the blog and just click on Archive September and go to Oil, Wind, and Fire, this is what I find to be a helpful blog that you can just read through and give you some ideas on how to talk to customers about boiler enhancements, about boiler replacements, about what they call payback. And understand there's no real, I've always hated the word payback because payback seems like someone's going to write them a check, or give them money, and it doesn't work that way. People say, what's my payback? Says, well, see, there's no payback with a boiler because a boiler isn't a slot machine. All right, it never comes up triple cherries and money never comes spewing out the relief valve. All right, you're never going to reach 7 years, and the utility company is going to look at the book and say, oh, looks like we owe the Fredericksons some money. Hey, Frank, get out the checkbook. It doesn't work that way. A boiler, my friend, is a pig that eats fuel and poops heat. What we're aiming to do is put that pig on a high-fiber, low-fat diet, basically. So it poops a lot of usable heat with as little amount of fuel as possible. This blog will help give you some ideas on maybe how to talk to some folks about that. That study I was referring to on outdoor reset was performed by the Center for Environment and Energy in St. Paul, Minnesota. They showed outdoor reset controls save an average of 20%, depending upon the boiler. What they found was somewhere between 5 and 15%, actually closer to 10 to 15% for a cast iron non-condensing boiler. And actually, here's a look at the actual report. This is a table from the actual report that they produced. So here's your high efficiency tune-up. All right, 4 to 5% savings per year. Then adding a reset control to a cast iron boiler, and here the estimated savings based on an independent research is 10 to 15%. This is good hard documentation you can share with your customers. Down at the bottom is the website. If you go to mncee.org, write that down, gang, mncee.org. There's a little search button there too. Just type in boiler reset and hit click. You'll get about 7 or 8 different articles and pieces of research that they have done on this particular topic that'll help you with your customers. There'll be a link to this particular page and then a link to the actual magazine article that on this report. So good independent information that'll back up what you say when talking to your customers. Very good? Excellent. So that's good for you. Here's another one, number 3, and this is number 3 because of the Three Stooges. This is a two-stage thermostat. Another simple thing you can do to make a heating system more efficient would be to add a 2-stage thermostat to an existing system. This is kind of poor man's outdoor reset. Stage 1 goes to the relay itself, and that turns on the circulator. Okay, so stage 1 will fire the circulator. Stage 2 is actually wired to TT on the boiler. So when stage 1 can't keep up, meaning there's no longer enough residual heat in the boiler, well, then the boiler is going to fire. This does a couple things. First, it makes use of the heat we already paid money to make, and secondly, by reducing the core temperature of the boiler, when stage 2 fires, that boiler is going to have a reasonably long burn time, even in the shoulder conditions. So this kind of a poor man's reset actually does a pretty nice job. It involves some rewiring. You've got to make sure you get the right thermostats. It has to have smart staging, so you don't actually get cold before you get warm again. That would be counterproductive. And you really need some mass in your boiler. It really works well with a cast iron boiler with a fair amount of mass involved. I actually have a friend who did this. He has an old American Standard Arcaliner from about 1958 that's dying, but he just doesn't have the money to replace it, and he doesn't really like paying what he's been paying for oil. So first simple thing he did was to add 2-stage thermostats, and it certainly helped. It had an impact, again, maybe 5–10%, but it certainly helped. Okay. And your wiring up in this case, again, stage 1 goes to the relay to fire the circulators. Stage 2 would go to TT to fire the boiler. Pretty simple, pretty straightforward, and a fairly inexpensive add-on. Paul Draper says, this is what I do for morning warm-up and set the reset more aggressive than normally would be set. This helps saves additional fuel. Sure, there you go. Mo, got to run. Download the webinar later today. Pick up where I left off. Okay, very good. Looking forward to hearing from you. Excellent. Thank you, Mo. Appreciate it. Number 4 is a buffer tank or hydraulic separator on a modulating condensing boiler. You want to add mass to a mod con. Short cycling is a way of life with modulating condensing boilers because there's so little mass, and in many cases, especially with radiant floor heating systems, we tend to aggressively zone, which we should for comfort. But the combination of microzones and low mass at the boiler leads to short cycling, which harms the efficiency and also leads to premature wear out of components within that boiler. We're already seeing that with boilers losing fan switches, and different kinds of controls are being worn out prematurely, 3-4 years into their life with this high efficiency, very expensive equipment. And a lot of it just has to do with simple short cycling. By adding a hydraulic separator, we help short cycling. By adding a buffer tank, we really control short cycling. So it's a good thing versus the best thing to do. So by adding this mass, we do reduce short cycling, and we can enhance overall efficiency. For ModCon, your basic piping arrangement is like this. When the boiler loop is flowing, the zones don't feel it. When the zone pumps are flowing, the boiler doesn't feel it. So we keep those two things separate, and we help reduce the short cycling of the boiler. It doesn't eliminate it. It's not a bad thing to do. It's just not. It's better than not having a hydraulic separator, but it doesn't fix the problem permanently. It helps just reduce its impact. Oops, sorry. Here's a couple of pictures of one. Here's the smaller of the two Taco hydraulic separators. This is used more for separation. There's not a ton of mass there, but it helps a little bit. This is used more for hydraulic separation. Over here you see this actually comes from Hydronic as a standard component with their wall-hung boiler. In fact, their newer versions are much nicer than this. They're kind of insulated and look a little bit better, but this was the first version they had to help add mass for the separation and for the slight impact it'll have on short cycling. You really want to deal with short cycling, though, gang, you need a buffer tank. Okay, you do need a buffer tank. That'll add mass to a ModCon boiler, a lot of mass. What this is, it's just a big old insulated tank that holds boiler water. That's all it does. It'll prevent short cycling even under partial load conditions because there's just more mass involved. Pretty simple. Boiler's piped in and out of the tank, and your zones are piped in and out of the tank. It's not an indirect. There's no heat exchanger in there. It's just a big storage tank with 4 holes in it. Okay, and it's just holding water. It's ironically enough, we're adding mass to a low mass boiler. Okay. Your basic piping arrangement here with a ModCon boiler. Note that your indirect is piped off prior to the buffer tank, which is good, which is what we want. And then on the other side of the buffer tank, you have your heating zones. And if you look at it, really, a buffer tank's nothing more than a big honkin' hydraulic separator. Okay, that's really all it is. It's a big honkin' hydraulic separator. The question, though, asked down here is pretty common. How do you size the buffer tank? Well, here's how you size the buffer tank. It's a simple formula. First thing you want to do is you want to find the minimum boiler firing rate. Boiler has a 5-to-1 turn-down ratio. It's 100,000 BTUs, 5-to-1 turn-down ratio. Your minimum firing rate's 20,000 BTUs. You determine the boiler's minimum firing rate, and from that, you subtract the BTU load of the smallest zone under design conditions. What's the BTU load of the smallest zone? So you subtract the smallest zone from the minimum boiler firing rate, and that will give you the BTU surplus. And that'll give you the BTU surplus. Next, multiply the BTU surplus by the desired run time for the boiler. Usually we use a figure of about 10 minutes. When that boiler fires, we'd like it to run for 10 minutes. So BTU surplus times the desired minimum run time. That'll give us the cycle factor. The cycle factor. Next, we will divide the cycle factor by our old friend delta T times 500. Delta T is not the boiler delta T, it's the heating system delivery delta T. Let's say it's fin tube baseboard and it's 20 degrees, or cast iron radiators and it's 20 degrees or 25 degrees, whatever you want. Whatever that number is, delta T times 500, we multiply that, and then we use that we divide the cycle factor by that number, and that'll give us the tank capacity in gallons. So let's do one and write it down as we go. Let's say I've got 100,000 BTU ModCon with a 4-to-1 turn-down ratio. In this example, my minimum firing rate is going to be 25,000 BTUs. The smallest zone I'm dealing with is 8,000 BTUs, good size zone. To To find my BTU surplus, I'm going to subtract 8,000 from 25,000. That'll give me 17,000 BTUs extra. It's my BTU surplus. Next, we'll multiply 17,000 BTUs by the minimum 10-minute run cycle, and that gives us 170,000. That's our cycle factor, 170,000. To find out the size of the tank, we'll divide the cycle factor by the delivery delta T. In this case, we'll use 20. Let's say it's fin tube baseboard or cast iron radiators. We're using 20. Delivery delta T times 20, delivery delta T of 20 times 500, that's 10,000. 170,000 divided by 10,000, that gives us a 17-gallon tank. Now, you may find a 17-gallon tank. You look at the providers of tanks, and the most smallest I got to 20 or 25. Okay, use a 20 or 25. Going bigger doesn't hurt you any. Okay, going bigger doesn't hurt you any. Going smaller, you're not getting as much of a run time. It's just less mass there. So you make that call. If they have a 15-gallon tank, well, okay, 15, 17, you maybe call it good. If it's between a 15 and a 40, well, maybe you want to go with a 15. But just understand what you're doing if that's the decision that you make. And number 5 on the hit parade is add a delta T circulator to the system, a variable speed delta T circulator, where this circulator varies its speed based on what's really going on in the heating system, the delta T. Delta T tells us how many BTUs are being taken out of a heating system at any given point in time, because after all, GPM, the flow rate you need to deliver, is equal to the BTUH heating load of that system at that given point in time, divided by the system delta T times 500. So this variable speed circulator will vary its speed based on how many BTUs are being taken out of the system at any given point in time. So it wants to strive to maintain that fixed delta T. So let's say it's a standard hydronic heating system, and we're operating on a 20-degree delta T. Let's say I have 2 zones calling, and the pump is running and running and running. It has a sensor on the supply and the return piping, and it's sensing a 20-degree delta T. A third zone opens up. All of a sudden, that is an increase in the demand for BTUs, right? We need more BTUs. There's more load. Running at that same speed, since I'm taking more BTUs out of the system, almost immediately that circulator is going to sense that delta T starting to get wider. Maybe it goes to 21, 22, 23. It's starting to get wider. So as soon as it senses that change, the circulator, because what it wants to do is maintain that 20-degree delta T, is going to speed up, give you more gallons per minute. More gallons per minute is what's needed because GPM equals BTUH divided by delta T times 500. As zone valves close, the opposite will happen. That delta T will want to start to get smaller because I'm not taking as many BTUs out of the system. So that delta T will start to snug up. The circulator will sense that, and in order to provide the right flow to the system almost all the time, it's going to slow down. Okay? What the variable speed circulator is going to do, the double OVDT, what it's going to do is it's going to speed up and slow down based on how many zones are open, and it's going to speed up and slow down based on how cold it is outside. That's an important thing to remember, guys. It's going to speed up and slow down based on how cold it is outside. See if you can figure out how it does that and type that in if you know, because that's an important thing. Right? It always tries to maintain that design for delta T, and it'll always send a 20-degree lower temperature back to the boiler, which is good because that helps short cycling too. You put a PC700 and a variable speed delta T circulator on a cast iron boiler, what you've just done, folks, is make that boiler, you've given that boiler the potential to operate as efficiently as it possibly can. Okay, it'll operate as efficiently as it possibly can. That's Christmas, New Year's, and a ban on Chinese imports all rolled into one. So a delta T circulator plus outdoor reset is a great combination. Okay, so again, cast iron non-condensing boilers, absolutely. A friend of mine in Pennsylvania made one change to his heating system last winter. He took out a 007 and he put in a VDT, variable speed delta T circulator. It's the only change he made in his fin tube baseboard system. You know, one circulator, 3 zone valves or 4 zone valves, can't remember which. And because that circulator varied its speed and always sent the lowest temperatures back to the boiler that it could, boiler didn't short cycle under design conditions or under shoulder conditions, he noticed on a colder winter, and this is his particular example, in a colder winter, more degree days, his fuel consumption went down about 15% just with adding that circulator, which is remarkable. Now, again, your mileage may differ, but it is a heck of a thing to add to a system. Okay. So again, it's going to maximize boiler efficiency for a condensing boiler, and as you see here, with a modulating condensing boiler. If we're running at, say, 150 and we know we're getting a 20-degree delta T, we know the water temperature coming back is 130, look at where we are in terms of overall efficiency as opposed to over here, per se, or over here. You know, we're going to be much more efficient. We're going to get that low temperature back to a condensing boiler and to a non-condensing boiler to make it run as effectively as we can. And those, gangs, are the 5 things that we're dealing with.